All right, good morning. Today we are going to look at your study guide. So hopefully you guys submitted this by 9 a.m. this morning, and here is how you would check it. All right, so the students in Miss Lavelle's class were asked what month they were born. The results are as follows. So I'm not going to read each data point, but you can see the data points there. It says use the data to fill in the box and whisker plot. So what we need to do is take these data values and put them in order. So once again, I have done some upfront work to make it go a little faster. So we should have 3 1s, a 2, a 2, a 3, a 3, a 3, 4, 4, 4, 5, 5, 6, 6, 6, 7, 7, 9, 9, 10, 11, 11, 12, and 12. All right, so that is what we should have. All right, so we know that this one is going to be the median. So we are going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 on each side. So the median is 5. So the median of quartile 1 would be those two numbers. So that would be 3. The median of quartile 3 would be 9. We know that the maximum is 12 and the minimum is 1. All right, number 2. Match the following elements of the 5-number survey. So the minimum is the smallest data value, so that is E. We know the maximum is the largest data value, so that is C. We know the first quartile represents the lower 25%, so that would be A. Third quartile represents the first 75%, so that is D. And the median is that middle data point, so that would be B. All right, number 3. Okay, use the box and whisker plot below. Use the box plots to answer the following questions. So which period has a higher median? So first period or sixth period. So hopefully you can see that's the median. So the first one would be sixth period. Which period has the greater interquartile range? Remember, that's the difference between Q1 and Q1. I'm sorry, Q3 and Q1. So this one would be 96 minus 80, which is 16. And this one would be 94 minus 78. Sorry, had to look to make sure I had that right. So they are the same. All right, the middle 50% of first period, so that would be from here to here, so 2.6, so that would be 96 to 80, or you could say 80 to 96, however you wanted to write that. First period scores are they normal, skewed right, or skewed left? So I would have to say, this is a little bit longer, and as you can see, the data points are that way, so I'm going to say skewed left. And the bottom one, I'm going to say is skewed right. All right, use the data plots represented to data plots represent the number of apps downloaded in a given month by 18 randomly chosen students from 2 different high schools. So as you can see, A looks like it is skewed, and B kind of looks like a normal distribution type plot. All right, so let's read those questions. So it says, which statement below are true? The median class A is higher than the median of class A. So the mean of class A is higher than the mode. I'm sorry, the median. All right, so the mean, actually, let's look at the median. Okay, so the median would be those two data values, which is 3. And the mean, excuse me, I'm going to add them all up and divide by what we have. So we know that that's 2, this is 8, This is 15, 12, 10, and 16. So when we add those up, so 16, 10, 12, 15, and 10. So that would be 63 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, let me count that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 63 divided by 18 is 3.5. So the mean is definitely larger than the median. So A works. All right, then B says the distribution of class A shows a symmetric distribution. Nope, I would not say A is symmetric. C, the data for class B shows that most team members ran a distance greater than the mean. So since it's normal, the mean is going to be somewhere right here. So it's pretty evenly distributed, so C would not work. The range for the data of class A is greater than the range of class B. So the range here would be 8 minus 1, which is 7. The range here would be 6 minus 1, which is 5. So let's read. The data for class A is greater. Yep. So D works. E says 75% of the class A members downloaded at least 2 apps. So at least 2, so that means 2 or more. So I would say that would be correct because that's more than 75. And then F says at least 75% of class B members downloaded 5 apps or less. Well, here's 5 or less. So at least, yep, it's definitely more than 75, but it's definitely at least. So that would be F as well. So the answers to this one would be A, D, E, and F. All right, number 5. Mr. Eisen recently gave a science test. The scores were distributed normally with a mean of 70 and a deviation of 6. So that means we're going to create that curve, right? Even though that curve is not very curvy. So that gives me 70, 76, 82, 88, and then this one gives me 64, 58, and 52. So the probability that a randomly chosen student has scored between 64 and 76, so that's this range right here. So that would be 68%. The percent of students who scored below 70, well, that's that mean, right? So that has to be 50. The percent of students who scored no more than an 82, so that's everything below, so that's 97.5 because it's only leaving that 2.5% section. Okay, between 58 and 70, so 58's here and 70, so we know that this is that 34% and that is that 13.5. So when we add that together, we get 47.5. And it says the probability that a randomly chosen student has scored above a 76. So once again, that is going to be that 13.5 section here and that 2.5, which is 16%. All right, 6. A group of students measures the distance a toy car has traveled at different amounts of time. A table of the data is shown. What is the outlier? Well, as you can see, the outlier is 11 because that's the largest value we have. So when we got to find the mean, the median, the IQR, and the range of the data without the outlier and with the outlier. So we are going to do it without first. So my mean, once again, I've kind of did some upfront work. So that is 33.7 divided by 10. So that is 3.37. The mean with it would be 44.7 divided by 11. So that is 4.06. So we know when we go down to the bottom, the mean is going to increase. So we're going to check that down at the bottom. All right, the median. So if we put these in order from least to greatest, we would get 1, 1.2, 2.4, 3.3, 3.7, 3, 7, 4, 2, 4, 5, 8, 4, 9, and then I'm going to put that 11 here as well. All right, so the median without the outlier would be these two here, so that would be 3.7. Once we add that outlier back, that makes this one. So it's just 1, but it still would be 3.7. So we're going to say the median has no effect. All right. The interquartile range. So that means we need to know of this data what's the middle. So since 3.7, both of them, that means we include that value. So the middle here would be 2.4. Right? Because that would be this half of data here. So, yep, 2.4. So, IQR. So, that would be 2.4. And then of this half, it would be 4.5. So, 4.5 minus 2.4. So, that would give me 2.1. So, the interquartile range here, once we add the 11, would be, so now we're going to include this point, so 1, 2, so that would be 4.8 minus 2.4, so that would give me 2.4, so as you can see it increases, so we're going to say interquartile range increases. We know the range is going to increase, right, because once we add that 11, it's 11 minus 1. So that's 10, and then here would have only been 4.9 minus 1, which is 3.9. Okay, so range increases, and then that standard deviation is going to increase because we know that 11 is definitely a lot further away from the mean. All right, number 7, the test scores for 12 students are listed below. Which statement best describes the spread of the data? So we're going to write it in order. So 58, 60, 60, 61, 61, 62, 63, 64, 65, 67, 72, and 80. So it should be 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so it says the median of the data set is 62. Well, these two are my two data points, so that would be the median is actually 62.5, so we know A does not work. The set of the data is skewed because 58 is the only value below 60. Well, 58 is really not that far from 60, so we're not going to call it skewed. But if we're looking at that 80, it is a little bit further from the 72, so 80 is an outlier, which would affect the standard deviation. Yep. And this set of data is evenly spread. So I would say no, not very, because it's 58 to 80. So, all right, so it should be C. Okay, moving on to 8. So the table below shows the annual salary for 24 members of a professional football team in terms of millions of dollars. The team signs an additional player to a contract worth $10 million. So that means we're going to add a 10 to the end of that data. So what is true about the median and the mean? Well, without that data set, the median would be 1.4 and 1.5. So we were going to find that median, 1.4 plus 1.5 equals divided by 2, would be 1.45. Okay, and then once we add that data point, it shifts the median to 1.5. Okay, so it means the median does increase. And then we know what happens when we add a larger outlier that makes the mean increase. So we're going to say both, which is C. So both of them will increase. All right, 9. The number of dice per box in a truckload of boxes are normally distributed. So I'm going to draw that up here. Okay, so this would be 200, 204, 208, and then this one would be 212, 196, 192, and 188. Okay, so that would be what that looks like. All right, so we know that 68% of the data falls between here and here. So that would be 196 to 204. And then 95% of the data falls between 192 and 208. All right, number 10, the following numerical order sequence of numbers has a mean of 20 and a median of 25. All right, so that means we know that the median is going to fall between this 23 and the B. So what we're going to do is set up an equation. So we know that 23 plus B, so since there's two of them, divided by 2, but we know that the median is 25. So I'm going to multiply each side by 2 to get rid of it, right? So that gives me 23 plus B equals 50. We're going to subtract 23. So that gives me B is 27. Okay? So B is 27. So to figure the rest of it up, you're going to add 4, 11, 13, 23, the new 27 we know, 27, 28, 28, and 31 together. So when we add all that up, we end up with A plus 192 equals 20. We know that there are 10 data values, so that's why we're going to divide by 10. So to get rid of that, we're actually going to multiply each side. So we would get A plus 192 equals 200. Subtract 192, so A would be 8. So that is how you would solve that one. All right, number 11. The following histogram shows the height in inches of trees 2 weeks after planting. What is the tallest height of the trees? Well, if this is height down here, the tallest height is 60 inches. Right? So height is here on the bottom, so 60. How many trees are in the 40 to 49? So that's here. So there are 3. How many trees are at least 30 inches? So that would be 4 and 2. No. At least would be more than that. So that would be 12. Yeah, how many trees are at least 30 inches? So it's got to be 30 or more. So that should be 12. And then how many trees are less than 40? So here. So 7, 4, and 2. So that would be 13. All right. And moving on to number 12. 3 surveys were conducted about the time spent studying in math in one day, considering the relationship between the mean and the median. Then indicate the best measure of center and value, and the best measure of spread. All right, so we know that if it is skewed left, right, skewed left, that the mean is greater than the median. If it's a normal distribution, we know the mean equals the median. And if it's skewed right, we know that the mean is going to be less than the median. All right, so we've also talked about if it is a normal distribution, the best measure of center will be the mean. And the best measure of spread would be the standard deviation. And then if it's skewed, no matter if it's left or right, we will always use the median. And the best measure of spread would be the interquartile range. Oh, can't see that. Sorry. All right, so please make sure you are making corrections on your study guide. And hopefully you guys will study and be prepared for that test. Have a great day.